Oh God. This stuff is so difficult. I'm gonna fail this test. Do you guys understand Lewis dot structures?
Yes, a Lewis dot structure is the representation of an atom's valence electrons. Lewis dot structures are used to predict how atoms will bind together to form molecules.
So how do you draw the Lewis dot structure for hydrogen chloride then?
First, you find out how many valence electrons are in each atom. For hydrogen, since it's in group 1A, there's 1 valence electron. And for chlorine, since it's in group 7A, there's 7 valence electrons. So you get both of your atoms, hydrogen and chlorine. Now they're going to bond, so you have to determine how many valence electrons they have, which we've already done. 1 in hydrogen and 7
for
in
chlorine, since it's 7A.
7A, alright.
You do not pair the electrons in the valence shell first. You draw individual dots. These dots represent valence electrons. And then you go back to form pairs. So 5, 6, 7. Each atom wants 8 valence electrons because this is the most stable state. So these atoms are going to combine to form a molecule. Hydrogen fluoride.
Alright, so with the bonds, how would you draw that with a bond then?
Okay.
You would just draw a line just to between this part and this part, just to show that they're in a pair.
Awesome.
Pretty
Cool.
easy stuff.
Thank you very much. So the book talks something about molecular geometries. Do you guys understand that?
Yeah, well, it's kind of based on the Lewis dot structures. First you have to be able to draw the structure. Like, I'll show you with water. That's a good example. It's H2O. You have water in the middle because it is the least electronegative. Then you do the same thing we did. You have to draw out the electrons, all the dots. 6. Then you can draw your structure. You know, there are 2 unpaired electrons on oxygen. And there's 1 on each hydrogen.
So single bonds.
Yep. So you do that. And then you know you have 2 sets of
Lone pairs.
They go like this. And the reason I drew this like this is because these have a greater repulsive force than a bonded pair of electrons. So that's how it gets this shape. And by drawing the Lewis dot structure, we know that it's bent. And this affects the molecular geometry.
Alright, well, maybe I think I'm ready to try one. Why don't I use this ridiculous highlighter to draw a Lewis dot structure for CO2. Can I steal this from you?
Certainly.
Thank you. CO2. So C, carbon, has 4 valence electrons. And oxygen has 6 valence electrons. So that would be carbon, 1, 2, 3, 4, oxygen, 1, 2, 3, 4, 5, 6. Alright, so carbon would have a double bond, the oxygens, and then there would be 2 lone pairs on each oxygen. And there's a Lewis dot structure. Looks like I did it. Wow.
Do you feel comfortable for your test tomorrow?
Well, yeah, I mean, I know that these Lewis dot structures are a representation of the valence electrons in a molecule. And basically it shows how different atoms bond to form molecules. And then how the lone pairs, which are valence electrons, how they can vary the shape of the molecule, also known as molecular geometry, which can also affect how the molecules bond with each other.
I think you're ready. What do you think?
I think you're utterly prepared.
I love chemistry.